NCBM 0324, Section 1.1, Order of Operations, Part 3. So we've seen some pretty interesting examples. Last ones involve some fractions. Let's practice a little more with those fractions. Again, we're talking about order of operations. So we look for parentheses, exponents, multiplication, division from left to right. And then we end with addition and subtraction, again from left to right. Let's look at example J. We have an example J, 5 over 6 squared, divided by 5 over 12 plus 2 over 3, all that in parentheses. So order of operations, let's do parentheses first. I have 5/12 plus 2/3. So if I need to, and this is perfectly okay, maybe let's do a little scratch work on the side. If I need to figure out what is 5 over 12 plus 2 over 3, I'm adding fractions. So whenever I add fractions, I can only do this if my denominators are equal. My denominators are the same, right? Same thing goes with subtraction. Any addition, subtraction, denominators have to be the same. They have to have a common denominator. Well, in this case, looking at 12 and 3, my common multiple, my common denominator, will be the 12. I can get both of these denominators to be a 12. The 5 over 12 is already good, so that's nice. But the 3, I'm going to need to multiply it by 4 in order to make that 12. But if I multiply this denominator by 4, I'm going to be changing my fraction, and I don't want that. So then I'm going to multiply the top also by 4. So what we're really doing when I multiply top and bottom by 4 is like multiplying by a special version of the number 1, because 4 divided by 4 is simply 1. But it's this special version that's going to make the fractions work nicely. So that's why I'm going to use it. So I have still the 5/12, but then I have 2 times 4 that's the 8. 3 times 4 is 12. So now that we have the same denominator, I can add the numerators. And 5 plus 8 is 13. And we keep the same 12 on the bottom. So then our parentheses of our expression, let's go back over here to our actual problem. We have still the 5, 6. We'll deal with that in a little bit. But now in these parentheses here, I'm going to replace it with that 13 over 12. I simplified it down. Okay, so parentheses are good to go. Check. I do have exponents here, and you can kind of see the parentheses there. That's acting as both of these numerator denominators are going to get that squaring. So maybe a little bit more scratch work if we need it. If I'm asked to do 5 over 6 squared, one way I can view this is by applying the square to the top numerator and to the denominator. This can be done because it's division, right? Any division, that exponent, that power, can distribute inside. So then I have 5 squared, and that's giving me 25. 6 squared is 36. So I have my exponent done. Over here I can say this is 25 divided by 36. Divided by the 13 over the 12. Okay, we're getting there. It's looking a little cleaner, a little nicer every step. Scratch work, it's okay. We have enough paper to deal with it. Now let's look at exponents are done. Multiplication, division. I do see a division here, but I have a division of a fraction. And here's a nice trick when we're dividing by a fraction. Because I have a single fraction here, 13 divided by 12, I can do the following. My operation will switch to multiplication, but my fraction that I'm dividing by, so what comes after the division symbol, doesn't stay the same. It's going to flip. So we multiply by the reciprocal, we flip the second fraction and change the operation into multiplication. We'll see a little bit more of that later on in our course. But just think, from a division of a fraction, we flip and multiply. So now we have a multiplication. And the nice thing about multiplying fractions is we multiply straight across. So I don't have to do any common denominator anymore. I'm just simply going to multiply straight across. And when I do that, I'll end up with 300 on top divided by 468 on the bottom. Now this is an okay answer, but I do notice that both of these values, my numerator 300, my denominator 468, both of these values are even. So that means I can simplify my fraction. And in any problem, we want to simplify our fractions, right? Especially when you're dealing with any homework computer system that you may have in your class. It's going to want your answers in fractions. So once we simplify this down, we're going to end up with 25 over 39. And if you're used to simplifying fractions, we could have even done this over here before we multiplied across, right? The 12 and the 36 could have reduced down, leaving us with the 25 up top. This would have been a 3 left over, right? This becomes a 1. This will become a 3, because 12 into 36 is 3. 3 times 13 is the 39. Right? So however you want to simplify these, you want to make sure that you go all the way that's possible.